And welcome to a lesson on solving equations. Just saying that probably makes you feel kind of excited about what's going to happen today because this is a topic that a lot of students usually do pretty well with, and it's just one of those where you have a set order of steps, a way to go through it, and it usually makes it a little bit easier to process. So let's get to the learning targets, which are to see the structure of an expression, to see where it's coming from and why we do what we do, and then to know how to solve a multi-step equation. So some vocabulary that we'll need to know for today. Inverse operation should be one that you already know, and it's just to perform the opposite action to solve a problem. So if I was doing a game of opposites and said add, you'd say subtract. And if I said divide, you'd say multiply. And if I said to square something, you'd say square root. Okay, so it's just the inverse or opposite operation. And the property of equality is the official way to say whatever you do to one side, you have to do to the other. So I'm sure you've heard that phrase before. The property of equality is the actual way to say that. So let's go ahead and look at the first example. So for our first example, let's find the value of x that solves the equation. In this case, identify the operations that have occurred to x first, and then we're going to reverse them. Okay, so if I'm going to do what's been done to x, I have to know what's happening to x in order for this to work. So let's make a list and start with the fact that we have x minus 3 over 2 plus 7 equals 23. So the first thing being done to x is that we are subtracting 3, okay? And the next thing that's being done is division or dividing by 2. And the third thing being done is adding 7. Now all I'm doing is following the order of operations, okay? So if I was to know the value of x and substitute it in, I would say it's 10, subtract 3, then divide by 2, and then add 7. And it looks like I missed my divide by 2, so I apologize. All right, now let's go ahead and reverse this. So we're going to start from the bottom up when we solve our equation and do the inverse operation. And as I'm saying this, it may not make sense until you see it, and then it's going to make perfect sense. So I'm going to start right here and not add, but subtract 7. And if I do that to both sides using the property of equality, I'm going to end up with 16, and over here still x minus 3 over 2. Now, if you've ever had trouble figuring out what to do next, you probably have never thought about what we just did, which is the opposite of the order of operations. So if I divided by 2, I'm going to undo this by multiplying by 2. Okay? And hopefully this is starting to make so much more sense for why we do what we do. So if I multiply by 2 on both sides, this 2 cancels out. 16 times 2 is 32. And now I'm left with simply x minus 3, which if I was subtracting 3 as the first step, I'm now just going to add 3 and end up with x equaling 35. And there you have it. Hopefully that's bringing some more understanding to why we do what we do when we're solving an equation. All right, looking at the next one. Solve the following equation in 2 different ways. The first time we're going to do the reverse of the operations, and the other time we're going to do distributive property first, and I'm going to show you how it doesn't make a difference, but it will bring up a different way to solve. So looking at example A, I have negative 2 times x minus 4 in parentheses plus 8 equaling 2. And if I wanted to make a quick list of things that we are doing, let me bring this list down here so we don't get in the way of what we're going to do, and you may want to do the same as well. First thing is parentheses first. So what are we doing to x? We are subtracting 4. Okay? And then the next thing that happens is that multiplication, that number outside of parentheses. So we're going to multiply by negative 2. And the third thing, there's only 3 steps, is the adding of 8. and usually adding or subtracting go last, okay? So adding 8. So there is the order of operations if we knew the value of x, but we don't know the value of x. So our job is to solve for the value of x, and how we're going to do that is we're going to reverse the order of operations. So reverse these 3 steps. So I'm going to start at the bottom and work up and do the opposite of each one of these. And watch how easy this is. So if it says adding 8, I know to subtract 8 as my first step. Pretty cool. So negative 2, x minus 4 is still there. This makes a 0 pair, and now 2 minus 8 is negative 6. This step complete. Next one, opposite of multiplying, divide. So I'm going to divide by the same number, negative 2. So instead of distributing, which you probably have done a lot of, I'm going to divide, and that's going to make 1, and this will leave x minus 4 equaling negative 6 divided by negative 2 would be positive 3. Second step complete. Working from the bottom up, now subtracting 4, but I do the opposite or the inverse and add 4. I do it to both sides because I'm using the property of equality, and look at that. I've gotten my answer of x equals 7 by reversing the order of operations. In this next one, instead of reversing the order of operations, I'm going to do what we been taught to do, which is distribute, okay? So if we were to distribute this first, no problem, you're still going to get the right answer, but it would change how you get there and would probably add a few steps that you don't want to take. So now I've just increased all of those numbers by multiplying by negative 2. Then I'd have to combine like terms. So 8 plus 8 would be 16 equaling 2. Next up, I'm going to subtract 16 by using the property of equality. You're not going to hear me say whatever I do to one side, I do to the other too much more after we get through this lesson. And then after we subtract 16 on both sides, I'm going to divide by negative 2 using the property of equality, and I will get the same answer, like I said, of 7. But in this case, there were 1, 2, 3, 4 steps. And on the other side, by just reversing, there were only 1, 2, and 3. So you did save yourself a little bit of work by reversing the order of operations, and hopefully you have a slightly better understanding of what to do when. All right, for our last example of the notes, we have to be comfortable with decimals. Now, the coolest thing is, in 9th grade, you get a calculator for everything. So please make sure you are using that calculator. Now, in this case, if I was to try to make a list of operations, I really can't do anything, right? I can't really subtract these because they're not like terms, and I can't subtract these because they're not like terms. So if we thought of this as like a balance beam where these had 2 different sides and I needed to try to somehow find x, the first thing I'd want to do is bring those x's together. Now, I can only do that with inverse operations. So if this is positive and this is positive, I could subtract them. Now, it doesn't matter which one, but my rule of thumb is move the smaller coefficient, and that's the number in front. So whenever we're looking at 5 cents or $1.70, well, the 5 cents is always smaller, right? Now, if you're not real comfortable with subtraction, please don't be afraid to use that calculator. And 1.7 minus 0.05, and you'd end up with $1.65, right? If you had $1.70 and you subtract 5 cents, it's $1.65. And if you think of decimals in terms of money, I find it to be easier than just looking at it as a regular number, okay? Now, we have numbers on either side of the equal sign, and even better than that, we have integers because they're both negative. Now, because I already have an x on this side, I want to empty that side and add 16, okay? It'd be a little trickier if I added the 7. I'm not going to get into that, but understand that if we have a negative 7, positive 16, we'd end up with 9. And now we have this $1.65. Now, this is multiplication, so don't think of it as anything else. And we're still doing the inverse of operations. So the opposite of multiplication is division. So I'm going to divide by $1.65 on both sides. And I'm going to think to myself, how many times does 165 go into 9? And don't think too long or hard about it because you got a calculator. Okay, so let's use that calculator to find the answer. So we're going to just take 9 and divide it by the $1.65. Okay, so you end up with 5.45454545, and then this 5 at the end that kind of breaks the pattern. Well, the 45 is actually repeating, so we want to write that as a repeating decimal. The 5 was rounded, and therefore that's why the pattern stopped, because the calculator simply ran out of space. So this would be, forgot my first number, 5.45. To show a repeating decimal, we just kind of put a line over the numbers that are repeating, in this case the 4 and the 5, and that's equal to x. Okay? I hope you would enjoy this quick little lesson on equations, and I'll see you on the flip side.